people who just came, there are cookies over here, and they are celebrating the end of classes. So today in the lesson, whenever you feel like it, raise your hand and ask for a cookie. So I still don't have the full information about the final exam. We said, so there are 4 instructors for the course. We submitted the questions to the course coordinator. We still didn't get any feedback about the questions, so maybe we submitted questions which are too hard, maybe too easy. In general, so you should expect that some questions will be of the format that you've seen in the web work. So basically, something for which the answer can be formulated with a short answer, and on the final you should expect the asked to provide a justification. So like web work, you will not be allowed infinitely many attempts and not provide any justification for the answer. On the final you do have to provide a justification and you only have to choose one answer. But still, I believe that at least one of the problems in the final will be just taken verbatim from the web work. One of the problems will be taken verbatim from the first midterm. So we'll review those. We probably won't have questions of the level of difficulty of your homeworks. The homeworks were a little bit to stretch your knowledge, to stretch your problem-solving abilities. You will have some problems which will be harder than the web work questions. And on our website, I posted a file with 15 questions which are, well, I think on more or less all the topics that we cover. And they are, maybe some of them harder than the typical web work questions, so please review those as well, try to solve them. Once I have the more, once I get more information about the final, like how many questions there are, what percentage of the final covers material after the midterm, what percentage covers material before the midterm, I'll send you an email and I'll let you know all the details. Next week I will hold office hours, maybe not on the same schedule as during the term. I'll let you know later. I'll have to reserve the room. So once again, I'll send you some emails. For today I plan to solve a couple of questions which are a little bit surprising. So I hope you will enjoy solving those. And that will be very much fun. So let's solve some questions. Show that x to the power of 3 over 1x prime is, and here comes the surprise, 0. So the question asks you to show that the derivative of this really complicated expression is in fact very, very simple, just 0. So I'll let you work with this question for a little bit, 3-5 minutes. And if you have questions, if you get stuck, if you want a hint, or if you want to put your raise your hand, then I'll come. can discuss the question with your neighbor, get started, or with me, raise your hand. Also, if you feel that you've made enough progress, come and reward yourself.
There's a boundary determining your relatives.
Let me give you some hints and some more time to give these hints. So there are several ways to solve this problem. One, well, you see such an expression, it has complicated power. One possibility how to find the derivative would be to try logarithm differentiation. So take this expression, find logarithm, try to differentiate the logarithm. Another possibility would be to write this expression as e to some power and then differentiate it. And well, the algebra should show you that the final answer will be 0. So let me give you another 2 minutes with these hints. Alright, let's see. So how many of you managed to find the derivative? How many of you started and are pretty sure that like in a couple of minutes or by the end of this lesson they would find the derivative? Okay, so some people know how to start. Does anyone remember or have an idea how to start on this question? Has anyone understood what kind of hint I was given? Okay, yeah.
So I started with a chain rule.
The chain rule. So the chain rule, yes, how would I play the chain rule? What would be the external
First I
function?
have x to the 3 divided by ln x times the derivative of 3 over ln x.
So you think that this is right?
No, 3 divided by ln x. The derivative of 3.
Okay, so where does this term come from? What is this?
That's the original.
The original thing.
Yeah.
Why? Can you remind me what chain rule is?
Yeah, it's the derivative of the outside function times the derivative of the inside function.
Okay, so what is the outside function and what is the inside function? So okay. I want to write it as u of v of x.
Yeah,
Can I?
so it'd be like so would u of v be x to v?
If I want to write u of v, I should write u as a function of v. No x's.
Would it be u to the v
U.
to the v?
Okay. So it's a very good point. Unfortunately, this is not going to work. But it's very important to understand also why it's not going to work. So here I have a function of x raised to a power which is another function of x. In the chain rule, I will have a function of one parameter, and this parameter being another function of x. And the reason we have a problem here, the reason well, I don't expect to get an actual answer here, is because, well, raising to a power is a function of two different parameters. One is the base, and the other one is the power itself. So here I have x raised to some other function that also depends on x. So I can write it as a composition of simple functions of some parameter in terms of x. It's not a simple function in terms of 1 of x. It's not. So the chain rule doesn't seem to be applicable, at least right away. After some algebra, we will apply the chain rule. So maybe I'll ask you, once you do some algebra, how to apply the chain rule.
I was going to say, should we set the base x to e in order to
Okay.
start with the chain rule?
So to start with the chain rule, it makes sense to try to rewrite this function as e raised to some power. Maybe the power will be even more complicated than it is now, but at least it will be e to some power, and we know how to differentiate e to power b. So let's rewrite this as e to some power. So maybe somebody else. How can I start writing it as e to some power? Let's say I want to write x as e to some power. What power would I write? I think that somebody started saying, but I didn't hear it.
E to the ln of x.
E to the ln of x. That's right. E to the power ln of x is x, because ln of x is the power to which you should raise e to get x, by definition. Okay, so here I have x is e to the power ln of x. So I can write x raised to the power 3 over ln x as e to the power ln x, and then raised to the power 3 over ln x. Let me write it as e to some power. Here I have first e to some power and then raised to some other power. how can I write it as e to just one power?
You multiply it.
Multiply them. So I know that a raised to power b and then raised to power c is the same as a raised to the power b times c. Okay, so I multiply this. X times 3 over 1x. Can I simplify this?
Yeah.
How?
Probably cancel out.
The logarithms cancel out. One is the numerator, the other one is the denominator. So this whole thing is just EQ. Okay. So we simplify this expression as e raised to the power, which is just 3. What is the derivative?
There is it's zero because it's a constant, not a.
Okay. So even though the first impulse is to say e cubed, well, the answer is not e cubed. The answer is 0. It's not derivative of e to power x. Derivative of e to the power x would have been e to the power x. But this is derivative of e to the power 3. And e to the power 3 is just a number. Well, approximately, I don't know, 24 or something like this. And derivative of a number which does not depend on x is 0. The rate of change of something constant is 0. So here, the derivative is 0. Even though the original expression was complicated, after doing some algebra, it turned out that it is just a number, e cubed. Why did we start doing the algebra? Well, because that's the general trick. If you want to differentiate a function which looks like one function of x raised to some other function of x, you rewrite the base as e to the power 1 of the base, and then differentiate this complicated expression. In this case, the expression turns out to be really simple. That's not the only way to solve this equation. We have, so let me write this number 1. Let me try solution number 2. Another idea how to differentiate a power, quantitative power. We know a technique called logarithmic differentiation. If you have an expression which involves products, quotients, and powers, try to apply logarithm first and then differentiate. So our function x raised to 3 over 1x clearly involves powers. So it might be useful to apply logarithmic differentiation. How do we apply logarithmic differentiation? Well, first we compute what is logarithm of y. It's ln of x to the power 3 over 1x. Now, how can I simplify this?
Move the power to the front.
Move the power to the front, thanks. So I know that ln of a raised to the power b is the same as b times ln a. So this 3 over 1x, the power, times 1x. And once again, I have a simplification right here. I can cancel out 1 of x. So what the result of 1 of y is 3. Next step in logarithmic differentiation is differentiate both sides. Ln y prime is 3 prime. So what is ln of y prime? And let me ask you. Now it's about general.
Well, I mean, I didn't use a signal when I just rewrote it as e
solution.
Yeah.
In this solution, I want to follow exactly the steps that we follow every time we do logarithm differentiation. So I want to find what is derivative of ln of y in terms of y and y prime.
Is it ln of y times y prime?
Okay, almost. Almost. So derivative of ln of y. I want to write it as a composition, ln of y as a composition of two functions. What would be the external function? What would be the internal function?
Ln of y.
Ln of v, and v is
V.
so if I want ln of y to be u of v of x, what should it be? So I want ln of y of x to be in fact u of v of x. We've chosen u to be ln of v, and v is so I want to write it as a composition of two functions. Y is already a function of x. Now I have a more complicated function, ln of y of x. So I've said that external function is ln of, and the internal function is
Is it y?
it's y of x, yes. So the external is ln, the internal is y. Now the chain rule, du by dv, derivative of u is what's derivative of 1? 1 over v, and what's derivative of v? The derivative relative to x. So x is a parameter, y is some function of the parameter. So what's the derivative of y of x?
Y prime of
Y
x?
prime. We have no way to write it in simple terms. It's just the derivative of y. So here we have 1 over y times y prime. That's the derivative of ln of y. If y is a function of x, then derivative of ln of y from the chain rule is 1 over y times y prime. So just for you, the only difference with what you said in the beginning, it's not that here we have the external function, we have the derivative of the external function. Okay, so now I have 1 over y times y prime is 3 prime, and 3 prime is 0. 3 does not depend on x. So y prime is 0 times y, which is 0. Okay, so yeah.
How do you know when just looking at something when to use, like when using the ln of both sides? Is there something?
So when logarithm differentiation works,
Yeah.
if you have an expression which looks like this, something times something times something, maybe times something, some power, maybe some quotients, maybe the quotients are all symbol powers. So if you have an expression which matches this kind of pattern, it is reasonable to apply logarithm to both sides. So if y is such form, apply logarithm to both sides.
So you would just set it to one and
Take the logarithm, because the logarithm can be simplified. When it will not work is when you have an expression here, logarithm differentiation works. expression of such a form, something plus something, or minus something. So one complicated expression plus another complicated expression. Logarithmic differentiation should not work, because there is no simple formula for one of the sum, for one of the so logarithmic differentiation doesn't work, but usual differentiation should work. So maybe in some examples, if you have something simple, like just one complicated expressions, no products, no powers, that's usual differentiation. So here I don't see a product, I don't see a power. It should be just usual differentiation. Similarly, if I had something like e to the power x plus sine x, also usual differentiation. A product of two simple expressions, something like e to the power x times sine of x, well, it can be done using usual differentiation or using logarithmic differentiation. Both will work. If you have something really complicated, like e to the power x times sine of x divided by cosine of x multiplied by 5 to the power x squared plus 3. That's obviously the question about logarithmic differentiation. It's not to say, or if you have a complicated power, like sine of x raised to the power cosine of x. So these are cases where logarithmic differentiation is applicable, and that should be applied. It will simplify your life quite a bit. It's not to say that usual differentiation wouldn't work in these cases, but it will be way longer and way more complicated. So in this case, you'll have to apply product rule maybe 2 or 3 times, maybe quotient rule 1 time. It will be complicated. And here you have a complicated power expression. Here you'll have to rewrite it as e raised to the power 1 sine x times cosine of x, and then the chain rules. Once again, it will be somewhat complicated. Logarithmic differentiation will be much simpler.
And on the test, will you always tell us if you're using
No.
differentiation?
No. So on the test, you will be given expressions, and the question will be differentiate. Use whatever methods you want. It might be logarithmic differentiation, one of the rules, chain rule, product rule, quotient rule, a combination of those. I guess for implicit differentiation you will know, because it will be a question like find the tangent line to a curve, and then you know to apply implicit differentiation. But we won't tell you, you should know. Yeah?
I have a question about the solution number 1, like the idea of raising the, I don't know, the problem with using E,
Yes.
like never occurred to me, so I was kind of wondering how you identify that and how you kind of like think of using that method
So,
instead of just one addition.
We discussed, I think it was the lecture before we covered logarithmic differentiation, we discussed the following thing. If you want to differentiate such a function, you would first rewrite it in this form e to the power 1 of f of x times g of x, and then differentiate it using the chain. So that's if you look in the lecture notes, I think it was under the title standard differentiation.
Sorry?
I think it was under the title standard differentiation. So if you want to differentiate one expression that depends on x raised to the power of expression that also depends on x, you want to get rid of dependence on x in the base. So you rewrite it as e to the power 1 of the base, and then multiplied by the original power. Other questions? So next question will be so next question is like this. Let L be the tangent line graph of 1 over x and a comma the point a comma b on the graph. Find the area of the triangle formed by x-axis, y-axis, and L. So maybe before I give you time to think about it, let me draw a picture. So here I have a graph of a function, y is equal to 1 over x. On the graph of this function, I choose a point. I should also add a condition that a is positive. I have a point. At this point, I draw the tangent line. And then I'm interested in the area of triangle formed by this tangent line, x-axis and the y-axis. So I can draw a picture. How does the graph of 1 over x look like? Okay, yes, like this. So if is 1 over x is really small when x is large, it is really large when x is small. So it looks somewhat like this. It has another branch when x is negative, 1 over x is also negative. So it's kind of a mirror image of this. That's the graph of y equal to 1 over x. On this graph, I have a point with coordinates a and b. At this point, I have a tangent line, so something maybe like this. This is L. And the question is, what is the area of this triangle? Formed by the x-axis, y-axis, and the tangent line. So let me give you 3-5 minutes to start thinking about this question. How to start with this question. And any amount of progress that you make on this question is beneficial for you. So if you just come up with some plan, write down this plan. If you know what kind of combination will be relevant, perform this computation. So do something to advance. you are stuck and don't know how to start on the problem, start by trying to find the equation of this line. Or if you don't know how to find the equation, start with finding the slope of this line L. Okay, so how many of you found the equation of the, let's start with the slope. How many of you found the slope of the line L? Okay, very good. How many of you found the equation of the line? Okay, so you probably need to do it. So unfortunately we don't have much time, and I want to say a couple of words about like exam writing strategy. So let me solve this question with you. So first of all, the strategy. How to solve this question. It asks for area of a triangle. If I want to find the area of triangle, well, this triangle is obviously a right angle triangle. So I'll have to know what is this length and this length, because then the area is this times this divided by 2. On an exam, if this is the only thing that you know, do write it down. It might earn you 1 point out of, I don't know, 6. So if you know at least something, write it. Don't leave blank pages. I mean, even if it's something like, this question is probably about differentiation, well, it probably will not earn you a point, but you know, it's worth writing. Okay, so I want to find this and that. This point, so this distance would be the height of this point. This point would be the intersection of the y-axis and this line. So I probably should find the equation of this line. Well, let's start with the equation of L. So for an equation, I should find the slope first. What is the slope? Well, the slope, since it is a tangent line to the graph of this function, should be the derivative of the function. So it is derivative of 1 over x at the point a. So it's the derivative of this function evaluated at the point x equal to a. What is the derivative of 1 over x?
Negative 1 over x.
Minus 1 over x squared. Thanks. And I want to evaluate this at the point a. So I just should plug in, instead of x, I should plug a. Minus 1 over a squared. Okay, so it's minus 1 over a squared. That's the slope. I also know a point on L. What point is on L? A comma B. I know that this line passes through this point. So equation of L, what's the equation of L? Well, equation of a line with this slope and that point on the line. Difference in y is the slope times the difference of x. So it's y minus b is the slope times difference in x. x minus a. That's the equation. Next part, this is something that I will probably want to work with. So I better simplify it a little bit. Y is minus 1 over a squared plus x plus 1 over a and plus b. So I rewrote this equation. Open the brackets, brought the b to the other side. So that's the equation of L. Next, I want to find this point. Let's say that this coordinate is y0 and this coordinate is x0. Just to give it some names. How do I find, let's say, y0? Set x to 0. That's the point on this line where x is equal to 0. So set x equal to 0. In this equation, y0 is minus 1 over a squared times 0 plus 1 over a plus b. So it's 1 over a plus b. How do I find x0? Set y to 0. And then I have 0 is equal to minus 1 over a squared x0 plus 1 over a plus b. Now solve for x0. Bring this to the left side. 1 over a squared x0 is 1 over a plus b. And x0 is 1 over a plus b times a squared. Area of this triangle. What is the area of the triangle in terms of x0 and y0? I want the area. So the Pythagoras theorem will be applicable to the length of this.
It's
Other
1
side.
half base times height.
Yes, 1/2 base, which is x0, times height, which is y0. It's right angle triangle with sides which are horizontal and vertical. So it is 1/2 x0 we found there, here, a squared times 1 over a plus b times y0, which is, where is it? 1 over a plus b. Okay. In a way, it is an answer. It already gives me an answer in terms of quantities which appeared in the formulation of the question, in terms of a and b. Well, but I told you that today we'll be solving surprising questions. So let's see why this answer is surprising. And it is surprising. Let's simplify. Is b an actually independent quantity, or can I express it somehow in terms of a? If I know what a is, can I find somehow what b is?
Yeah.
It's 1 over a. So simplification. B is in fact 1 over a, because this point lies on the graph. It's not just any point in the plane, it is on the graph. So it should satisfy y is equal to 1 over x. Well, let's simplify this expression. So area is 1/2 times a squared times 1 over a plus 1 over a times 1 over a plus 1 over a. So it is 1/2 times a squared times 2 over a times 2 over a. Can I simplify it now? What is the answer? 2. So here's the surprising part. This area does not depend on the point A, comma B. It is exactly the same regardless of what point I've chosen on the graph. So this area is 2, but so is this area, that area, or even if you go far, far away, you'll have a triangle which is very, very flat. Still, you'll have area 2. Okay, so maybe some words about writing the example. As I said, do not leave blank pages. If you know something, if it is, I don't know, strategy for how to solve the problem, what topic it is about, any computation which you think is relevant, write it down. Anything which is not written down is not going to be graded. If you know how to solve a question, explain every step. Make sure that the solution is actually readable. Because that's important, because we will be reading it and we'll be grading only what we read, not what we intended to write. And, well, I guess, thank you and have the best of luck. I will not continue it in the second term. We'll have a different instructor. So, thanks a lot.